Hello, and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of constant rates of change. This is standard 7.4a in the great state of Texas, and we are using item number 9, which is a new item type called graphing, of the 2023 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. Alright, so we have a snail moving at a constant rate. Okay, so that constant rate is going to be very helpful for us because we have a distance of, it looks like 20 inches in half an hour. When I'm thinking of that constant, that makes me think of this constant of proportionality that we see here on the linear equations. We're going to draw a straight line, k equals y over x. So that constant is going to be my slope, constant of proportionality, y over x, right? It's the change in y over the change in x. And let's see, well, we've got 20 inches. And I see my inches are on the y-axis right here. So I can kind of put that right there. And then I've got half an hour. And I've got, time is on my x-axis over here. So it looks like I've got 20 inches in half an hour. So how could I plot that? Well, I've got, I guess I don't have a half hour, but I can plot one right there, and my 20 would be right there. So if I wanted to plot this, I actually can plot in halves. It doesn't have to be whole numbers, but let's get a few other points just to see what we have here. What if I were to double it, right? So if I were to double my numerator and double my denominator, make an equivalent fraction, it's going to keep my same constant. I can have, let's see, 40 inches over 1 hour. So there we go. That's a little bit better. So we don't have a fraction in our denominator. So you notice that first point that I plotted was an x of 1/2, a y of 20. So the second one is going to be an x of 1 and a y of 40. Notice how I just doubled it. So there we go. I've got my 2 points, right? And as always, with this constant of proportionality, unless they tell you it doesn't start at the beginning, we can always add the origin, right? So look at this. I've got a straight line, right, coming through all of these points right here. And all we need is that line. We just need 2 points. So I could double this again, right? That's going to be 80 over 2. So if I didn't want to try that half or the origin, then I could do this 80 over 2. So right now I've got 4 points there, not the world's straightest line. That's why they don't want me to draw on it. They do want me to go ahead and just plot it. So let's play around with it. So what we do is we put our very first point on there by hitting it once, right? So I'm going to put my first point at that 140. If we want, we can drag it around a little bit, but I want to keep it right there because I want my second point. Remember, we had it as 1/2 20 or 280. I'll go ahead and do that 280 just so we stay on the whole number. So once I click that second point, you notice the line appears. Now what I could do is you see I'm shifting between either of these points. If you want to remove one, you just double click one of the points. But I could also drag it. And see, there's that point 0.5 over 20. And you notice how, well, of course my line's not that straight, but the line stays the same if I move it down there and if I move it down to the origin. Any of these work because they are going to be on that exact same line with that same constant of proportionality. Now if I drag it over here, that's going to change it. So I could have my 140, I could have my 1/2 20, or I could have my origin 0, 0. I can even move this all the way up here, up to that 3, 120, and it's all going to work. So that is my answer.